Hello and welcome back. Recall when we were first introducing what we're going to be studying this semester, we described all of these subcategories of physics. The one that we are going to be focusing in on for the majority of this semester is the subcategory mechanics. Mechanics itself also can be split into two subcategories, and the first being kinematics, which we have been focused on up until present. And kinematics concerns itself with describing an object's motion. So what kind of quantities do we need to be familiar with to be able to describe an object's motion? Well, we studied those in the previous videos. An object's position, its displacement, the distance, its velocity, its acceleration, its speed at a certain time. All of these quantities are important in being able to fully describe an object's motion. The second subcategory within mechanics is called kinetics or dynamics, and it concerns itself with the causes or the reasons behind an object's motion. And we'll tie these two together at the end of this video. We'll make a connection between kinematics and kinetics. So kinetics and dynamics is completely focused on Newton's laws. Newton in his lifetime quantified all of the motion that we can see with our eyes in the entire universe, and then in his spare time he developed calculus. And you can see that in kinematics, a couple of times I talked about derivatives. That has to do with the field of calculus. Newton needed calculus to be able to fully describe the field of mechanics, and so he developed calculus as well as the laws that are necessary to quantify everything we see in the universe with these detectors that are built into our head called our eyes. So we're going to look at his first three laws, and then in a later video we will be looking at the fourth law, which will be the universal law of gravitation, and those four laws again allow us to quantify all of the motion that we can see in the entire universe. So Newton's laws. The first law is called the law of inertia. Okay, so inertia, what is inertia? Inertia is just a fancy word for mass. Okay, mass is going to get the symbol m, and it's going to have units of kilograms. Not grams, but kilograms is the standard unit for mass in the metric system. So the law of inertia. Inertia is, again, just a fancy word for mass. The law of inertia states that if there are no unbalanced forces acting on an object, then that object will remain in a state of constant velocity. Okay, so now remember that constant velocity means uniform speed in a constant direction. So recall that velocity is a vector quantity, meaning that it has both a magnitude and a direction. So in other words, for the object to maintain a constant velocity, it must have a uniform speed and a constant direction. If either one of these change, then the velocity is no longer constant. Okay? So state of constant velocity, we can describe the state of constant velocity as a state of equilibrium. And there's two different types of equilibrium. There's static equilibrium and there's dynamic equilibrium. So static equilibrium means that the object is not moving at all relative to the frame you are looking at it from. Dynamic equilibrium is a velocity that is not zero, but again is constant, meaning that it is moving at a constant speed in a constant direction. So two types of equilibrium. There's static, where the velocity is equal to zero, and then there is dynamic, where the velocity is not equal to zero. Okay, so Newton in his first law says, hey, because objects have mass, they tend to want to continue moving in a state of constant velocity. And only way to change them from moving in a state of constant velocity is to exert an unbalanced force on the object. In other words, it has to be tugged in one direction harder than it's being tugged in the other direction. So the law of inertia, Newton tells us how objects will behave in the event that there are no unbalanced forces acting. And let's back up just a moment. What is a force? Okay, well, let's go ahead and define that. What is a force? A force is just a push or a pull, okay, and can be exerted by you, by me, by gravity due to a planet like Earth or the Sun or Mars or Venus. Springs can exert forces. Ropes can exert forces. So we'll be looking at all these types of forces as we move on in successive videos. What about his second law? Well, if in his first law he tells us how an object will behave in the absence of an unbalanced force, in his second law he's going to tell us how an object will behave if there is an unbalanced force acting. So if there exists, this little symbol right here, the backward E, is there exists an unbalanced force, then the object will accelerate. Okay, now remember that we realized back when we were studying kinematics that acceleration means there's a change in the velocity. So that means if there is an unbalanced force acting, then either the speed and or the direction of the object is changing. So acceleration, remember, gets the symbol A, and it is a vector. So acceleration is going to be equal to the sum of all of the forces that are acting, and this sigma sign comes from the math language, and from the Greek language, and it just means sum of, add all the forces together, divided by the object's mass. Remember, the symbol m is the symbol we use for mass. So the acceleration of the object is equal to the sum of all the forces acting on the object, and if you add them all together and you don't get zero, then that means there's an unbalanced force. This is a vector sum. In other words, we have to be careful. Forces not only have magnitudes, but they also have direction. In other words, the effect of an object, the effect on an object is different if I exert a force in one direction versus the other direction. It will be moving differently. In other words, its velocity will have a different direction, okay? So we have to be careful about this addition. It is a vector addition. So what kind of units are we going to have for force. Well, let's look and see. If I isolate force, it would be the product of mass and acceleration, right? So the units for force, and remember, when I put brackets around a quantity, that means I'm just looking at that quantity's units. So the units for force are going to be the units for acceleration times the units for mass. The units for mass are kilograms, and the units for acceleration are meters per second squared. And in honor of Newton, we're going to call this a Newton. And of course, we're not going to write out this whole word every time we want to use this unit. We're going to just abbreviate it capital N. So Newton's second law says, hey, if you add all the forces together that are acting on an object and you don't get zero, then that means you have an unbalanced force acting. The object will accelerate. It'll accelerate directly proportional to that unbalanced force and inversely proportional to its mass. So the more mass of the object, the smaller the acceleration. For the same unbalanced force, the larger the acceleration will correspond to smaller masses. Newton's third law is that forces come in pairs. Okay, and what does that mean, forces come in pairs? Well, it means you can't have an isolated force, okay? There are no isolated forces. So for every force, there is an equal and opposite force. In other words, I'm pushing down on the ground pushes back on me. I'm pulling up on the earth is pulling down on me. I push down on this table, the table pushes up on me. Every single force has an equal and opposite force. And it's very easy to identify that Newton's third law pair by just changing the nouns. So I push on earth. Me and earth are the two nouns. Switch them. Earth pushes on me. All you do is switch the nouns and the direction, and you've identified the Newton's third law pair. I push down on the table pushes up on me. Again, just switch the two nouns and you have the Newton's third law pair. So there's no existence of isolated forces. They do come in pairs. The Newton's third law pair is found by just switching the nouns. Okay, so this is an introduction to Newton's laws. We'll be focusing a lot more in on how to apply them for the bulk of the rest of the semester. They are very subtle. There's a lot of depth associated with them, so we're spending, again, the bulk of the semester in this field of mechanics. Lastly, before we wrap it up, notice that acceleration appears in Newton's three laws. Okay, his second law specifically, and acceleration also appears in kinematics. So this is the tie between kinetics or dynamics and kinematics, is through the acceleration of the object. So we'll pick up on there next time.